Okay, so I'd like to just give you an example for the C9. One of them is how to name an alkyne and also how to name an alkyne and alkene together. So in the first example I have here for us, I have an alkyne, then it goes to the alkene. So obviously we need to start from number 1 to the alkyne, and then my blue color is not very visible, sorry about that. So anyway, we have 1, 2, 3, 4, 5, 6, 7. We realize that the alkene is a Z isomer. So I put a Z here. So we have a start with the Z, and then we say Z hept. Hept is the number 7 carbons. 4 is the indication where the double bond is, that comes first. Then we have 4 in, and then I have uh, 1, which the 1 is not very clear here. 1 in. So the in again is to indicate where the triple bond is. So again, I read it over: Z hept 4 in 1 yan, like alkyne yan. The next one I put the double bond first, so this would be 1, 2, 3, 4, 5. I'm sorry, 1, 2, 3, 4. Yes, 5, 6, 7. So it's 7 carbon. So I start with hept, 1 in, 3 in, like alkyne. I have trouble pronouncing that. And again, this double bond here, there is no E or Z. So let's look at this one. So this one, we have to decide numbering system to give the first number to in or to the alkyne. So the rule is we give it to in because it's a E, not a Y. So then in that case, then we have 1, 2, 3, 4, 5, 6, 7, 8. So the alkene gets the number 3, not number 5. So this become 1, 2, 3. So it says Z isomer. So it says Z stereoisomer. So we become a Z, a little bit faint, but if I read a Z oct, we have 8 carbon, 3 in, or N, actually 5 in, like alkyne. Now, what if I have a stereocenter there? So let's say if I put the Br here, then we have to look at this stereocenter and decide is it R or S. So we know that this is highest priority. Second priority would be here, and third priority would be here. H is away from us, so we can ignore it. So there will be 1, 2, 3. So this is an S isomer. So we have to show that, and the name, again, it's not very clear. Actually, this time I'll write it. So this would be S, and the Z, remember this is a Z isomer here. Then we have to say where the brom is. We have say 7 bromo. Then the number of carbon comes right after that, which is oct. We have 8 carbon, so oct. Then we have the double bond, 3 in and 5 yang for the alkyne. So this would be the name for this structure. Again, the double bond takes lower number than the triple bond. Next example I have is how to go from it, for example, this alkyne to an alkene, but that alkene has something added to it. So we have the alkene and the alkyne. We count the number of carbons from the cyclohexane. We have 1, 2, 3, 1, 2, 3. So the number of carbon attached to cyclohexane hasn't changed, but something, and also we can say 4 here, right? We can say 4 here. So we have 1, 2, 3, 4, 1, 2, 3, 4. Okay, but something added to it. So we have now something different added to it. So we have this 3 carbons. So these 3 carbons actually added to it. So we have to remember a couple things. We have to remember that the alkyne has acidic hydrogen, becomes a nucleophile. And then we need to know what the alkyne or the alkyl halide is to react these two together to make this product. As we learn a little bit in the chapters 8, going backward is nice. So we're going to practice that a little bit more next few weeks. So we look at the alkene that we want to make. We decide that this double bond actually came from a triple bond. So if you have a triple bond here, as I draw over it, so this triple bond actually, if you have that triple bond, right, add hydrogen gas and Lindner catalyst to it, it becomes this isomer, which is the Z isomers. Remember these Z isomers? So we need to do a Z isomers. So how would I make this triple bond here to convert that to this double bond that we need? So this triple bond and this attachment to it again comes from the acidic hydrogen and the nucleophile. So the nucleophile, again, if I draw my little bond things to it here, is these 2 carbons. So these 2 carbons, the carbon on the right has a negative charge, and it's a nucleophile. So this nucleophile basically reacts with the electrophile to make this compound. So the electrophile that we have is a bromine, or it can be iodine, can be Cl, and it has 3 carbons. Remember, we needed 3 carbons. So if I add these 2 together, I make this one. Once I make this one, I can go back and make the double bond. So how would I make this nucleophile? Add that nucleophile from the alkyne. So it's the same alkyne we had on top. So this alkyne has, remember, attached to it 1, 2, 3, 4, and here is 1, 2, 3, and 4. So we have a H there. We can use sodium amide as a base, and this is an acid. So P transfer, we have a P transfer, and we make the nucleophile transfer. We make the nucleophile, and the nucleophile is ready to make the triple bond with the attachment, and then we can add basically Lindner catalyst and hydrogen gas to make this one. So that answers the question. Okay, so now we have some backward reaction again. So we have 2 carboxylic acid, and we want to make this carboxylic acid, and remembering how to make them. What triple bond did we have to make these 2 carboxylic acid? That's the question. So my suggestion to you is always put the 2 carbons together next to each other. So these 2 carboxylic acid, put carbon here and carbon here, and these 2 carbons actually were attached as a triple bond. And when we add oxygen and water to this, so we add oxygen and water to this triple bond, we make this 2 carboxylic acid. So it's sort of the reverse. If I have the triple bond here, add oxygen, ozone. I said oxygen. Ozone. Here, sorry about that. Ozone and water here, so we make this 2 carboxylic acid. So we're going backward. So the key to going backward is both for here and alkene is to put the C double bond O next to each other, and those 2 carbons are the 2 carbons that it was triple bond. Thank you.